data is one of those things that maybe you all who are online have started to read in the news. Everything from politicians are using big data to, everywhere, to storytelling's big. Netflix is now using big data to create content. So I thought it was a great opportunity, since we have this webinar, to bring someone who is specific, who is a scientist, who understands all of this, that for many of us is very messy. So, I think this is a great opportunity for me to learn. So let me, let you do your thing. Mark, welcome.
Hi, good evening. I'm Marck Vaisman, and I am going to be giving an overview of what big data and data science is. And it's really sort of an honor to be here to talk about this within this industry, the media industry, which is, I know, is really embracing this. So I'm going to give kind of a quick overview of just touch on some high-level subject areas on what big data is and really how to best use it. What can you do with it, essentially. I'm definitely an industry outsider, but I want to try to share my knowledge and put it in perspective so that the folks that are listening can understand what it is and think about ways they can use data for their purposes, whether it's creating content or selling it or whatever. So what I really wanted to do is spend a few minutes sort of talking about what is this thing, big data. Everybody's talking about it. So let me start by introducing myself. So I'm Marck Vaisman. I am a practicing data scientist. I've been working in data for many years in industry. Currently, I do data science consulting, anything from data analysis to data visualization. I work with large and small firms. And I'm based in Washington, D.C., and I also run a nonprofit group called Data Community D.C., where we do all sorts of educational events regarding data stuff. So again, that's just the intro. And first I wanted to say that data is everywhere. It's everywhere from both the online and the offline world. On the online side, you've got data from being generated from social media sites, Twitter, Facebook, YouTube, everything. There's data that's both machine generated, so it's data that gets generated from operations, from all the back-end infrastructure, everything, and then there's user-generated data. Every time you're navigating, every time you're browsing, every time you're doing something on your phone, some of it is intentional and some of it is unintentional. Unintentional meaning that just by your behavior, there's data that's being collected at some point in time. And then intentional, it's just like, for example, you like something on Facebook, you're sort of implicitly saying that you're I don't know how to say this, you're endorsing something, right? So that's a reflection of your beliefs, of your likes, desires, etc. Mobile. I mean, we most of us have smartphones these days, and that's a machine that's communicating back and forth, and there's records being generated. And I'm not even going to touch about the whole sort of big brother and privacy issues, but the reality is that there's a lot of data. There's sensors all over the place. Data is being collected from sensors, weather sensors, science sensors. Really, it's really mind-boggling. And of course, in business, and really the advent of data within business is the fact that a lot of data has been collected over time that a lot of companies, a lot of businesses didn't really know what to do with it. And now they're really understanding that there's a lot of value hidden in those data sets. And that data can come from finance, from operations, from marketing. And for example, Netflix is a great case study here because Netflix is just they've always been a data player. They've been collecting all of the data. I don't know if you guys are familiar with it, but Netflix a couple of years ago launched a contest called the Netflix Prize, where they offered $1 million to anyone who could develop a better recommendation algorithm than they had done. And a couple of, many teams, this was actually done in almost 4 years ago in 1999. The contest ran for 3 years and closed in 2009. Anyway, the team that won got $1 million. They didn't end up implementing it, but they've really learned a lot about data. Science, we've all heard about this miraculous particle called Higgs. I'm going to butcher this word, but I don't want to say the wrong one. Higgs boson.
The God particle?
Yes, and of course in politics, with the Obama campaign, they used a lot of data science for targeting, and of course Nate Silver with his predictions and whatnot. Anyway, so the point is there's data all over the place. That sort of brings me to the next topic, which is like this other term that you've probably been hearing about, like what is data science? Data science now has a Wikipedia entry, so that puts us on the map. And essentially, data science is a combination of things. It's a combination of math, computer science, statistics, engineering, whatnot, and it's really a process, right? It's a process from working with data that's stored in all of these systems, this data that lives somewhere, and it's the process of processing the data, exploring it, analyzing it, creating predictive models, statistical models, doing explanation, whether you're predicting, visualizing, and then of course at the end you're really presenting an idea. So and I really like this because it's the theme here is telling a story, right? So with big data, it doesn't have to really be big, but with data in general, you're using data to tell a story. You're doing an analysis, you're testing a hypothesis, you're doing some analysis, and then at the end you're presenting an idea, you're presenting a story. I like to call data science kind of the modern approach to the scientific method. For folks that may have studied this in school at some point in time, in the scientific method, you think of an idea, you hypothesize, you design an experiment, you collect your data. That's where kind of data science comes in. Like today, the data, you're not maybe designing an experiment, or you are, but you get it, like you're working with the data itself. And then, of course, it's gotten tremendous growth because of the ubiquitousness of data, as we saw in the previous, before, and also the availability of raw computing power. Now you can actually launch a computing cluster on the cloud for cents on the dollar. So, someone's asking a question if it's significant data or not. Some of it may be, some of it may not be. I mean, that's a part of this process is distilling that signal from the noise, understanding what is relevant and what is not. And then, going back to the whole data science thing is the fact that you're drawing techniques from computer science, artificial intelligence, statistics, and math. A lot of these disciplines were doing similar works. They were calling it different things, but at the end of the day, you're all trying to do something. You're modeling, you're creating a model, you're creating a prediction, you're trying to understand what's happening. So that's really kind of what data science is. And of course, the practitioner is the data scientist, so someone such as me. I love this quote because it's really, there's been a lot of talk as to what is a data scientist and what is not, but someone tweeted this a while ago, and I just think it's hilarious. It's a person better at statistics than a software engineer, and better at software engineering than any statistician. Now, the funny thing is I'm neither. I'm not a software engineer, and I'm not a statistician, but man, I know how to work my way around data. Anyway, just a little bit of humor here tonight. It is almost one. What is big data? Big is a relative term. Let's see here. I'll get to that in a second. So big really is a relative term because it's really depending on whether you can fit it in memory, you can fit it on a single disk or computer. It's really relative. I mean, the reality is that big is sort of vast quantities. I mean, that's most people think of it. There's really two kinds of data for those folks that are not too familiar with this process. One is called like long data. So imagine you have billions and billions and billions of transactions or actions. So for example, you're first surfing Facebook, and every time you click on something, every time you browse on something, like that's generating a transaction, but that transaction has limited number of fields. But there's billions and billions and billions. That's like really long. It's sort of narrow and long. that tends to be the case usually in business and anything that's online and whatnot. The other kind of data that can be considered big data is what's called the wide data, which is the fact when you have a smaller number of records, but it's very wide, and that's sort of a typical data set that's used in genomics and people doing bioinformatics and gene sequencing and that kind of thing. I think what distinguishes big data from anything else is the fact, well, of course, just size, right? It's usually always scattered across different systems. It's messy. It's incomplete. And that's what, like data, why not? That's funny. I'm watching the comments.
The comments are very funny.
Yeah, I appreciate everyone's comments. But really, that's what's called big data in the sense. And, and a lot of it, of course, it can be biased because a lot of these systems generate data kind of, there's the 80-20 rule, and then there's what's called the long tail, which you've heard, which is you've got a lot, like a small number of or a large number of transactions that are like equivalent to one thing, and then many things like down the end. So for example, the analogy back to Netflix is you're going to have perhaps a small number of people or that like a very large number of movies, but then you're going to have a really large number of people that each individually like one movie particular. I know that's a generalization, but to make the point. And then an interesting thing is also the fact that the uncollected data can be as important as what is collected as well. So again, I just wanted to give you an overview. And do you have a favorite? So let's see. Let me continue.
They're asking for your favorite way to sort, your favorite methodology, I guess.
It depends. To sort as in like to analyze it, to sift through it. Is that the question, or just like
make
to sort?
Make it not so messy, I guess.
There's all sorts of techniques. I mean, right now there's a great set of tools out there. For you've probably heard to sift. Okay, yeah. A lot of it is really common sense. I'll get to that in a second, actually, in my next in my next slide. So really, kind of tying this back is the fact that, like I said before, you really want to tell a story with data, right? You want to do some sort of analysis. You want to extract some meaning from your data. You want to answer a question, right? So really, if you're going to use data, start with a question in mind. Like, don't go diving. Like, don't go trying to find a needle in a haystack, because you're going to get lost and you're probably not going to get anywhere. So, when you're using data, at least in this sense, you want to perhaps understand what content is valuable, who's consuming your content, how you're going to sell a product, etc. Of course, that's my background. I'm coming from the business side. But always try to use it where you can focus on an actionable outcome, like something that you can actually make a decision and take an action upon. I mean, sometimes it's really interesting. I mean, I've had the case where I've been working with data that's really, really interesting, and you learn something that's interesting, but that's not really usable. So for example, like someone just asked an example of a question. I did some work last year with a large tech company that had a lot of low-level internet traffic data. And they were trying to see if they could use that to some degree and monetize it. So, after doing the analysis, basically the data in itself, like it's really interesting, like the stuff you can learn, but from a business perspective, it has no value. So I can't really say much more than that. But going back to my tips is really just like start somewhere. Don't do analysis for analysis' sake. And, start with a question, because sometimes you're going to start somewhere and answer a totally different question. Data is just one piece of the puzzle. It's not the be-all, end-all solution. Context is important. Data without context is not going to give you an answer. So, I mean, that's kind of really all I have tonight. just sort of one last thing. There is a book called The Bad Data Handbook. It's published by O'Reilly. I wrote a chapter in the book, and these are my 5 commandments of things that you should not do if you want to be successful. Do you recommend? Let me get to that.
Let's go through them. Okay.
Again, I won't. I just want to try to answer some of the questions that I got from the audience. So, thanks so much.
Thank you.
Okay. Questions, you guys?
So everybody get the Big Data Handbook.
I want to read these 5 commandments, though. Know nothing about thy data. Thou shalt provide your data scientist with a single tool for all tasks. Thou shalt analyze for analysts' sake only. Thou shalt compartmentalize learnings, and thou shalt expect omnipotence from data scientist Marck Vaisman. I love it. Thank you.
Actually, Mark, I'd like to see the data that helps prove the point of your omnipotence as a data scientist.
Well, there's been
I have total faith, Mark. I have total faith.
Mountains of data.
a lot of about that. You know, the whole, there's definitely a lot of hype around this industry, around this term. And, you know, as that practitioner, it's sometimes you go talk to people, a prospective client or whatever, and they have just these unreasonable expectations. You know, they think that we're magicians and that, like, we have this black box and we can just, like, pull a rabbit out of it. And, I mean, we can do lots of things. We can, but we can't do everything.